Oh, hey. Have any coffee? I do have a little bit. Mmm, good thing. Welcome to the stream. Oh, it's a little late, but I'm hitting it. By it, I mean weird code stuff that I've just been doing on the side. Um, about 10 o'clock p.m. Here in the middle of the United States and whatever part of the world you're in. Pray for us. Your thoughts and prayers are appreciated. And also say hi. Stop by. I'm trying to figure out how to get my chat window back in OBS in a way. Let's see. Well, I do have one. Let me just set it up if I need to. Twitch chat in this case. There we go. And make sure it's in the right place. Okay, here we go. There for you. Welcome to the chat room. Welcome to the chat. Send many messages, but there it is. So, stop by, say hi. I'm just doing my thing. There, block that. And okay, so what are we doing tonight? Well, check this out. I've been looking at, um, shout out to all the people who have a crossover between 3D printing and retro stuff, because I'm moving always I'm ebbing and flowing between the two all the time. But today I was looking at, bring it up, hold on, preview, there we go, preview. So this, you didn't know back in the day, um, Atari, through the help of Compute Magazine, put out, or Compute Books, put out this, which is the source code for Atari Basic. Um, and if you're into interpreters and just the way that like stuff was put together back in the day, and I've been having a little fun just kind of doing a little. I have this project that I did a while ago to support Atari Basic syntax and 6502 assembly syntax and stuff. There's probably better. I think there's better syntaxes now, and I built it for TextMate and Sublime Text, and you basically just make it's a it's a YAML file, and it's kind of structured, and it's not quite perfect. I know exactly what I have to do to fix a few things. There's a problem with expressions and so on where they're not like I didn't do expressions because I was like, oh, this is gonna make my head hurt. But if I take good notes and I do it right, I can do that. But basically, I built a syntax so it could highlight basic, and when you look at basic in Sublime with my plugin enabled, which you can get at my GitHub, um, it looks like we open something. So it looks like this. So that's what my plugin does. It just makes Atari Basic look like Atari Basic. It also, like, special characters are handled. So I actually have a, let's see, is it that one? No, it's this one. Yeah, you can see all the characters. There's a Unicode font that has all these characters in it assigned to a certain range. And so I just do conversion between the two. So when you're editing, you're using, you know, these characters, which are Unicode, but when you go to send it over to the emulator, it converts it over to the right characters, which is this is 0, for example, and this is 128, the little hearts. So yeah, it's pretty cool. These are just data statements. So each of those is 100 and some numbered characters, I think. 128 or something. Could probably do them shorter, 64 of them. Let's see. Work 4. There. Let's cut them in half. Easier to see. Um, so yeah, and this is basically, and I've also got it set up so you can put comments in that don't go sent over to the emulator, so it saves space your memory. If you have all these comments and things. And so I've been messing around with this and just like Atari Basics, very slow and kind of a crappy basic, but of course, you can make it really run fast now, so it doesn't matter. So you can do things with it, like make little games and stuff. The only things I would change would be like make like when it's running really fast, have the real time clock still run at the regular rate. Do weird things like that. But you want if the whole emulator is like running in a certain way, you kind of want you can just slow down your basic program, have it count to 10 or whatever, or uh, or use the clock differently. You set a sliding scale on it as to how fast it'll run. But anyway, Atari Basic is fun, and that's where I started from, was kind of messing with Atari Basic as as a young lad, and so it brought me a long way. And so I've been taking the source code for Atari Basic, which someone published in the format compatible with CA65. So it's basically it's a cleaned up disassembly, and it's got some issues. So I was just cleaning it up to make it match closer to what was in the source book, because in the source book, it's not just a book about how Atari source code was done, but it actually contains the entire printed source code of the program, like also kind of a disassembly that's been cleaned up. So a lot of it is messy like this. Like this is part of the meta language that describes the syntax of each command, and then there's tables that do the parsing and lexing of the. So there's some real there's a little bit of sophistication in what's going on, but at the same time, it's also a simple scheme. Like if you want to look at a toy, not a toy scheme, but it's like a working scheme for a fairly simple, small vocabulary, interpreted language. Atari Basic, or what was recently released, is Microsoft Basic, or the general version of Basic that a lot of these other basics refer to and are based on. They all follow similar conventions, although they do different things to be optimized or not. We get out of the boring part. So Alex, here's an example where you have set code in ACV at COX and INC COX. Character output, I believe, is what that's about. And then there's error, go to line too long error. So this is part of the interpreter, I believe. Um, so yeah, there's a whole set of elements to it. Of course, you have your basic editor part, which is like running the editor and taking input and waiting for the characters to come in when someone hits return. And there's actually a general editor in the operating system that any language can use, and Basic uses it. So it's a line. It's basically a line editor. Um, and what it does is allows you to just type in a line up to about 120 characters if you have the margins turned off. And you can hit enter, and then your interpreter can catch that and do whatever it wants with it. So that's what this thing does. It also allows listing input from a file where the lines can be a lot longer than that. I believe they can be up to 255 characters instead of just 120. And and then the lines can basically be, I think, up to 100 and I think it's some number of tokens, maybe 255 tokens, which includes like the characters in a string and so on. So it's a fairly interesting little language, um, and there's a lot of like it basically because it's got a limited number of entities in it, it's somewhat manageable, and so the number of lines in it are many. uh, Obviously, the source code is complex, but at the same time, like a lot of it is repetitive, and a lot of it is idiomatic. So you can look at it and go, oh, I see these 10 lines are repeated somewhat with variations here and there, and that's you know so it's doing similar things. You'll see a lot of this kind of like you know this kind of stuff, but this is where it starts out. It's like boom, cold start right away, and so you can kind of follow it. It's really well commented, uh, and as an interpreter goes, it's pretty neat. So years ago I started doing in support of my 6502 tools and being able to do Atari Basic. I wanted to be able to um, in, at some point compile this without having to open up a, you know, an actual emulator. So that's kind of what I've been working on a little bit on the side. Is a little interpreter slash compiler, or yeah, that'll basically tokenize the text that you put in and turn it into tokenized Atari Basic. And the process of that is very interesting, which I'll give you a little background on. When you enter a line like this, or like this, the first thing it does is, of course, it looks for a line number. If there isn't one, it assumes you want to run the command right away. So it puts a line, it puts it in line 32,768, which is one bigger than the maximum line number. So then it runs it from there. So the next thing it looks for is like token, or like something it recognizes, some kind of command, and it just sweeps over. So if I have something like print XYZ, all with no spaces, it'll still see that print is there, and it'll say, oh, that's I recognize, and then it'll assume you meant print, and then it doesn't care if there's a space or not. So that's part of the scanner. You got to remember to do that. You can do abbreviations. So REA is a good abbreviation for read. Um, RU period is a perfectly good abbreviation for run, um, and so on. There's a lot of like little abbreviations you can use, and that just makes it easier to type as you're editing it. But when you want to like list it and look at it, it's nicer to have the full listing. But I've been playing around with the tokenizer a little bit, and I started out in C back in the day, and I got really kind of like weary of doing C at that low level, and I was like, oh, this is going to take forever to do it in C. But of course now I'm, playing around with Python as everyone is these days, and it's just like such a rapid, quick, easy language for prototyping, and you just get through things so much more quickly with it. And so I've been picking that up, and before I knew it, the other day I was just screwing around with the data tables I already had, which were like, you know, here's some the basic commands with their abbreviations, and then some nice helpful defines to lay out what they are. And then what else do we have? I guess I could assign these like funky comma syntax, but this makes it more readable. Uh, and I don't suppose, and with Python, you don't care too much about performance. You care about performance where it matters, and if you really need performance, you can make C hooks and stuff. So then all the operators and functions are laid out as well. You can kind of see it's all this data. So I was like, well, I'll play with this data now, which I had in my C program at some point. It's called tokenize.cpp. And yeah, so I had all this data set aside for the C program, and I was gonna get into it, but I started from the wrong end. I should have gone for untokenize first, and I was like, well, that'll be easier, the easiest task. I was like, well, I'm going to start talking to AI about it. And of course, the first thing that happens when you start talking to AI about some project you have is that you're like, oh, well, I better lay it out in steps. And so you really think through stuff you haven't thought through before, or you have to lay it out in a plan. So it's a good habit I'm getting into, being able to do plans. So I did set out to do a plan, and I put out some comments for the AI, essentially. Here's the development plan. And as I was doing so, I was like, well, the first thing would be to have a loader where I can load the tokens in. Then I'll be able to list them, and I'll be able to robustly check that certain functions I have for printing tokens and checking and doing binary coded decimal and all that stuff will all work. And so I got all that stuff working at that point. So this now looks like this when I use it. I just do -L with a base file. It'll give me a basic listing. That's pretty cool. It doesn't do any special colorization, but I may add that later. Um, if I could do like something that would do Sublime or TextMate style colorization, but on a, that you could pipe through, that'd be kind of cool. But anyway, I'm sure Prettify could do something like that if it had the right syntax definition also. So yeah, I can do that, and I can do abbreviated listing, so it comes out more abbreviated. You can see that's pretty cool. And you can do see what else. -H gives you help. I haven't done the interpreter part or the tokenizer part, so yeah. You can load one and you can list it. And once it's loaded, that's all you can do so far is just I can go in here and I'm like, I can say list. It's not actually interpreting a line. I'm just seeing that it's the word list and responding. Uh, and there's no like list 10. I haven't done that yet. So it just says list. I'll get that working soon. List 10 comma 20 and all that. But basically, the next part would be to actually make a proper interpreter. The other thing it can do is the only other thing it can do is list like uh, print out the variables that are defined. Because what's interesting in Atari Basic is I was going to describe something about what happens in a tokenizer. Uh, After it gets the first token, or as it's going through the tokens, it's basically tokenizing each command that it recognizes and each token that it recognizes. So it's like, oh, print, and that must be a string. So I'm going to remember that this is a string of this length here. And it doesn't have to save the quotes per se. It just remembers string. And then it'll be like, oh, here's a colon. That means end of statement. So it'll save an end of statement token. And you'll see like restore, or maybe it'll be res period, rest period, resto period, something shorter than restore. But any of those abbreviations it'll recognize, and then it'll put in just a restore token, and then it'll have an end of statement token. And that'll be the last thing it'll do. So that's all that it does. Let's see. And then if you were doing a line like this one where it has dim and it's recognizing variables, when it wants to tokenize a variable, instead of tokenizing the name by itself, it tokenizes, it first recognizes, oh, this is a new variable. It's a string, and it gets all the info about it, and then it stores it in a table called the variable value table. And then it stores the name in a name table. And then it stores, and they all are in a certain order, and the order for the index becomes the token for the variable. So it's like 128 plus 0 is token 0, or the first variable, whatever it happens to be. And it'll just store a single byte for each variable. So in this case, it would say dim, and that would have token 80. And it would say, oh, this is the parenthesis of a dim, and it'll remember that token. And then it'll remember the number, the dimension inside of the variable um, itself. But I believe that the line is separate from that. So I could be wrong, but I believe that it remembers it that way. Because you could say dim e string like q, and it'll tokenize that faithfully. So it does remember when you define a variable that it has a name and that it is dimensioned, and it might have a size to it. But it isn't actually dimensioned until you run the program, as far as I know. I don't know. We'll look at that process eventually. Uh, when I get this tokenizer working, I'll describe it to you a little bit. It's really complex right now, and the only thing I have to reference is this long and very complicated 6502 source code. Some of it we can hide, which is good. Like when we look at this, we only really have to look at like everything from here. This column forward is the real source code, and the rest is like the binary that it gets stored. So we have to be a little careful because ASL A shows up twice, even though it's a single command. It's weird. It just does that, I guess, because that's the way the disassembler worked with this. But other than that, it's all very readable and fairly straightforward what's going on. But eventually, what I will do in the long run is take these, thousands of lines, and I'll recomment, or I'll add some comments as to like what the C code would be for, or the pseudocode, or even the Python code would be for a given line or set of lines. And each chunk will suddenly become like the basis of something which could run exactly in parallel, and a perfect analog to what the original parser did. And I would just be talking about the tokenizer. As for the runner is a whole other thing. So yeah, you've got the tokenizer, and then you have the runner. And then the program runner has to go through the tokens and then call the appropriate things and do all the appropriate stuff in response to each thing that it sees. And some of the stuff that it sees is like, you know, a token for a command, and then followed by a bunch of tokens that it expects for that particular command, depending on what the command is. And so it can recognize whether something's a syntax error because it doesn't see what it expects. That's pretty much, it comes down to that. It does a lot of checking along the way, and that's what the syntax checker is sort of about as well. It's like it tells it, oh, you should expect this token next, or this set of possible tokens, and then it has little references to like tests that it can call back to confirm or refute that those things are true about the code as it's parsing it. That's pretty cool. It does a good job of laying it out in the source code, and then of course they have a really good description in this book about how the whole process works, pretty much described like in detail. Um, the print routine begins at like, you can see here, for example, the tab value is maintained in the tab cell. The cell is initialized with the value of 10. The commas cause each argument to be displaced 10 positions after the beginning of the last argument. And you can set a different tab value if you want. So you can set tab widths before you do your printing. That's something I forgot. But yeah, so this is a little reminder that in your programs you can, you can change things, not necessarily with just poke commands, and then the behavior of basic will actually change a little bit. So that's one of the things that I will have to do in my interpreter is consider that a poke to a certain variable number or name or memory location is going to affect the way that the basic behaves. So it's actually going to have to use those memory locations or an array. Basically it's going to be an array. It's going to be the memory will just be an array in Python, a binary array, and it'll just grab the value there and use it, and then so the variables will be mirrored that way. It'll be interesting to do it that way, because yeah, normally you would just name a bunch of variables and then deal with the fact that they exist in memory later. Um, so another possibility is to just use a variable called ptabw and treat it as if it was in a memory location C9. But you do have to respect the poke changes that value, so it's easier to just have an array and just use that and index into it with an index named ptabw and let that be, which is already defined, by the way, as the memory location anyway. So you just look C9 into your array. So it becomes somewhat of essentially a basic emulator. There actually, yes, you wonder, was there one already found online that like did I look on GitHub to see if someone already authored something like this? And yes, someone has done a lot of a basic interpreter of something like Atari Basic, but it's not complete. And I don't expect this to be complete, but I do want to have some fun with it and like maybe do graphics and stuff. I think that'd be really hilarious. Um, so what do you think about that? I don't know. I think it'd be fun. Just checking Twitch to make sure I'm still alive here. I wasn't sure if it started. It did. It did. I'll check the chat too. I might as well and just make sure that. Oh yeah. Let's see. Where's that chat? Chat. Hey. There we go. And myself. Okay. Cool. I can talk to myself. Hey, me. Cool. I don't announce these streams, so I don't expect a lot of folks to show up. But yeah, I just wanted to share this while I'm here and kind of unravel some of my thoughts about it while I'm doing so. That you can help me work on it a little bit. Over the next coming days, I'm going to be doing a release of Marlin firmware. Maybe early in the, I'll be working on it over the weekend, cleaning up the last few things, and then maybe Sunday night or Monday morning it'll be released, and then we'll have a week to mess around with it. And And then while we're messing around with that and printing and having fun and trying to break things, you can report your bugs and I'll fix them up as best I can. And we'll look at doing a 2131 patch up release in time for 3D Printopia, um, where everyone's going to be going around saying it's too little, too late. The whole industry's moved on. I know how it is, but at the same time, we just gotta keep polishing our turd. We've got what we have, and Marlon ain't sitting still because it's we can't switch to RepRap firmware. We can't switch to Clipper. We have to live with what we have. So we are moving forward and continuing to improve and provide new tools for things like input shaping. So it's going to have a second life. So hold on, don't worry about that. And oh, I wanted to click this one. Boop. So update on Marlin over. Uh, they've been doing this to kind of wind down at the end of the day after a long day of Marlin. Working on a little bit of Atari Basic is kind of cute. I'll show you some one or two things that I cleaned up in Atari Basic. One of them was, let's see, Instead It by Sheldon Lehman, 3.3 is a little bit broken, so I've been cleaning it up. It's not a huge program, as you can, well, I'll bring this over so you can see that there you go. That's the full extent of this basic program. But basic is verbish. It's verbish. Let me word wrap it. This is how much basic is wrapped when you're actually working on it on an Atari computer, so it can look really dauntingly long. Like, oh my God, my program is growing so huge. So I took a lot of the comments from the commented article in SoftSide and started inserting them in between the lines, and I think I got most of them. So this is close. This is as close to the SoftSide code that you'll get for Atari Basic version of Instead. Oh, actually, no. I'm not sure what. I'm not sure actually, because now that I think about it, where was this published? I think I must have taken the comments out of the code and put them into these external comments. Well, either way, whatever I did, when you run it, what is Instead It, you might ask, and I'm glad you did, because it is. Let's see, is Turbo on? There we go. Hope I got to change something. There's an issue with the graphics. Not in. I have to use the old NTSC artifacts, and then it works. There we go. So Instead It, as you can see, it's a character editor. It's for doing, like character sets and stuff like that. So it's not a great one. I think I tried to write one myself, and I thought mine was maybe better. But it was based on having used this one and being like, yeah, it has most of what I want in it, but there's other things I want to do. Like I want to be able to, just pick a character by moving around in this grid here, and it doesn't have that. So I may modify this and add some of that. But it's basically, you to use this, let me see, you can start by pressing any key. I'll start with, oop, that doesn't do anything. It's waiting for me to prep a disk for save. Oops. Damn it. I'll have to reboot. Hold on. That's funny. Turn the artifacts off so it's nice and clean. There we go. You can see a little better. But yeah, we used to, you'd have to modify, if you wanted to modify your character set, you needed some tool to do it. This is kind of a sluggish one, but it does the trick. So you can say, E for edit. Which character? I want to edit the letter A, of course. And then you move your little cursor around, and you can, make a fancier looking character set or something. And little by little, moving on to B, right? So you can little by little build a character set that fits your mood. And then you can save it to disk as a file and all that. That's kind of the coolest part, is that it has it standardizes, that a file with this file extension contains the character data. And you can have one thing I would do is have it save, like, compare it to the ROM character data, and if it's only if it's different, like, save it and then compress it that way. But that's just me. But compression wasn't a huge thing because they're pretty small files. It's like 8 bytes per character and 128 characters, I guess. So what does that come to? Like 2K, something like that. Um, so yeah, no, actually 1K. So you have 1K of space. It's like a big deal. So that's pretty cool. But I've been cleaning that up, and that's pretty fun. Uh, and so yeah, now I have a listable. And word wrapping it just makes it ugly. But now, yeah, I have a listable listing of this very long Atari Basic program. But it's all, modern tools make it so much easier to work with. You don't have to worry about anything as far as, like, uh, not being able to copy paste parts of your code, and stuff. The things you would typically do in your back in the day was you would have to, like, do renumbering when you ran out of line numbers, and uh, to give yourself space to insert new lines and stuff. And then, like, yeah, I had issues where I was running out of space in my lines, and I had to use these renumber utilities, and they were hard. I mean, they were cool, but they were a little tricky to work with. They would have to because they would have to basically scan through the code looking for go tos and go subs and line numbers and change them appropriately. And lines are stored in 6 byte binary coded decimal in Atari Basic. So yeah, it's a rather weird feature of it. It stores them that way and stuff. Even though that not the lines on the front. On the front of the line, it's like 2 bytes in little Indian order. But when they're stored, like, inside of your code, all numbers are 6 byte floats, no matter whether they're integer like or not. Like, it doesn't matter. So one thing I would change with Atari Basic to make it better, and a lot of people did back in the day, make more optimized basics, was integer basic. If you needed floats, you could have them, but by default, variables were integers. So that was a really good idea. And, like, if you really wanted something to be a float, you could put a period in it, a decimal point. Uh, and yeah, pretty cool though overall. One of the tricks that we would have to do in Atari Basic was, like, name variables like n0, n1, n2, and then use those instead of numbers, because the numbers were 6 bytes and a variable is only one. So you could make your program fit if it was getting too big. You could make it much smaller by replacing all your small numbers with variables instead. And so that's done a lot. In this program, K1 is like for K for constants. That's what he did. What Sheldon did. And if you think about it, like, two numbers plus a plus sign, two variables plus a plus sign is still cheaper than 6 bytes for a float. But the other thing is, if you're doing that kind of thing, it is still treating them as floats, so it has to go and grab them and use them as, it has to use the float values. But, the fact that it's grabbing them out of memory, so it does take a little longer. Um, it doesn't necessarily run faster to use variables. On the other hand, because your program is fetching, well, yeah, it's still fetching the 6 bytes and stuff, but it's fetching one. Well, it would have to fetch the 6 bytes anyway, so that's kind of the thing. So yeah, it runs about the same speed, I think, for the most part. As I understand it, like, the memory accesses on the 6502 are pretty much constant. Like, it doesn't matter if you're near. There's no near and far penalty. It's just zero page penalties and stuff like zero page is cheap, and, like, if you do it directly, and as opposed, it's almost like having a 256 spare registers to use, because it's nice and quick. But uh, let's see. So yeah, pretty fun. So as a language goes, like, it's pretty fun. Let's see, what's another one that I made. I actually have a program that untokenizes itself. So that's kind of like one of the things I wrote. It's like, before I wrote C program, I got out Atari Basic and used Atari Basic to write an untokenizer, untokenizing itself. Before I realized, even like I actually was looking in the Atari Basic source book recently, and this was before I even looked at the source book. I was just basing this off of like websites and info there. But I looked at the source book and I realized, oh, it has some code for untokenizing too. I also have to fix that up. So yeah, right now you can see that my syntax lexicon works almost perfectly, but then it gets to something like this and it's like, oh, it doesn't understand this. So I got to fix that. It wants that to be a number because it's in an on situation. Also expressions, like I'm not sure how well it does expressions. So I'm gonna have to work on that to fix things up. Like maybe I can do this. Nope. Either way. But yeah, so there's a lot of this is a pretty cool thing because it uses jump table. Because you can say go to x plus 10 or whatever you want and make a little jump table. So that's what I did for all the commands, is a little jump table to print the right thing. And yeah, it's pretty neat. But the thing is, because it's reading its own memory, it can only untokenize itself, so it just reproduces its own output. But what I did was I had what I'm going to do is make the first line like 100 and move a lot of these down, and then you'll be able to make 100 lines that'll untokenize, and then the rest of it will just be the untokenizer, so you can just use it as for experimenting. That's what this is for, and I just threw it into the pile of the 6502 tools because it's useful. Um, Lines is, of course, just a thing for doing as fast as it can draw lines on the screen. And how fast is it, you may wonder? Well, let's take a look. Pretty fast. Of course, if you turn on turbo, it just goes like that. So you can see that it's pretty fast, but you can almost see the lines actually drawing because of how slow it calculates. The way that it calculates lines is it's doing the beginning and end are both floats, and then it converts them into integers. Um, One is a 16-bit integer because the width can be up to like 320. The other one's only a single byte because there's nothing taller than 255, or 256. So it can make the XY coordinates only 3 bytes. So there's some savings there, but those float conversions are a little slow. And then it's using a Bresenham algorithm to go between the start and end point. And if you know that algorithm, it's pretty snappy and efficient. But in BASIC, or I should say, and it's running in 6502. So it's relatively slow, even in 65. Even running on like I believe it's a 1 megahertz or 2 megahertz processor. I think the old Atari was maybe I don't know. I keep saying 56 kilohertz. No, what was that? Something else was 56 kilohertz, but it's pretty snappy. So yeah, anyway, it's a fun little language, and I'm just doing my part to save it for posterity uh, and make a tokenizer so that when I go from so that my 6502 tools, you'll be able to have a load a base file, and it'll just you actually I could already do that, is I could make it so you can load a .bas file and it'll show up as text. So that's one thing it'll do. I'll probably have a helper for that at some point. The Atari Tools plugin part of this that goes into Sublime contains a theme, and you need this font, and it contains the build power of Atari Basic, and Atari Basic dash run it's called, or Atari Basic pipe. No, here it is. Atari Basic Sublime build. If you've ever made a Sublime thing, basically you need some JSON to describe what your source code is going to be, what its context is, and that's defined by your source code syntax. So if I made an Atari Basic Sublime syntax, and that's this, and it defines that namespace basically. namespaces all the way down. I know Python people like that stuff. So we like namespaces, and that's what it's about. This is the Atari basic one, which needs work as well. Anyway, the point of that was, oops, instead it go away. Oh, done with that. That's the output of that untokenizer program. It's very messy, but I know how to read it. It doesn't actually do a perfect listing of the program. It just shows all the tokens in the program and labels what they are. So it's rather ugly. And let's see, I think I don't remember why I put this in. I think I was copying this to another. Yeah, I was using this for other purposes, so I can take that all out now. Boom, go away. Lemo. Yeah. So anyway, oh, maybe I know what I'm doing. Yeah, so basically I'm making a program that's gonna like output all the um, eventually output all the tokens, or I'll have a program that I can use to test, and it'll have all the appropriate tokens in it represented. Right now I don't have any program that's just got all the tokens. Like, and if I did, it would be like they'd be scattered around in programming logic way. So I'm just making a fake program that's not going to have any, it's not going to actually run or do anything useful, like, but it will contain all the tokens. And so if I list it, like it doesn't like line 2 at all, that's fine. I don't want it to run, but you can see it's like, it's a program that is going to have one statement per line, maybe two if it needs a break or whatever to test. And it's going to just demonstrate every single token, and I'll be able to use that. And if it lists properly, then I know that it works. So actually, I'm going to save this to my shared folder, which is labeled H inside the emulator, and this will be called all token. And we're saving a base file. And there it is. Now, if I want, I can use that as the basis for my testing of my fantastic new script. All token. There it is. Oh yeah, so all the variables that it has in it are few and far between. I do have a dim in there, I guess. B00. uh, there it is, dim B1. So yeah, that's cool. Recognizes that, and it recognizes there is an A string, even though I may not have dimmed it per se. Like I say, as soon as it recognizes something that it's trying to tokenize as a variable, that's when it says, oh, let's grab the rest of it, and then make a variable for it, an entry for it. And then from that point on, you're always looking at the token. The only other thing is, what's this strange extra space in line 54 and 55? What's that all about? So yeah, much to learn about my own work here, but it's coming along. I'm figuring it out. Yeah, so it's fun to play with these old languages and screw around with them and see what you can do. I did write my own like language on the Atari at one point to edit disk sectors and stuff because I wanted to be able to pass around a file that said, here's all the changes you need to make to this disk so that it no longer checks itself, or or so you can use a buffer that you've stored in RAM or whatever, like modify this game for an Atari for a 1200, for example. Uh, that was one of the things we were doing. We were hacking with 1200s and putting extra buffers in them, so it was a big extra disk buffer. So you could store we actually had it set up so you could store an entire extra floppy disk, like floppy disk 2, in the memory buffer, and so you didn't have to swap disks when you were playing your game. You just read it from memory, and that was pretty cool. Um, or we would swap them out. We would have like first we'd read disk 1 in memory, and then we would read disk 2 into memory. And sometimes I think at some point, I think when there were 48K disks, we did have it set up to read both. Or 2 disc games. Anyway, it was cool stuff. Looking back on that time, George was a real hacker. He had more backup as a hacker from he and his dad were like collaborators in that like engineering world. It was pretty cool. Um, my dad was off in his own world, so I didn't have a chance to like do as much collaboration. If he and I had met on that level, it would have been cool because like I knew he was into like radio, and he built his own like he tried to build a Heathkit computer. It never worked. They kind of gave up because they are complicated. Like, how do you test it once you built it? It doesn't work, you know. Like that's the really the next part. You need an oscilloscope, and they're expensive. but uh, but like if you know if he had wanted to build hardware and I could build software, that would have been cool. Anyway, onto the bridge. We look at all these tokens will be are apparently coming up correctly. It looks correct to me anyway. Oh, and what about the abbreviation? Hey, there's the abbreviated ones. Cool. So cool, all those tokens work. And these are all the commands in order with the line numbers represented. Same as the token itself. So 13 is the token for trap, 42 is for put, 52 is csave, and so on. And then this one is going to be CHR string is going to be the 55, I believe. And 54, I think, is arithmetic assignment. I don't know. I have to look them all up from that point on, or put comments on them so I can more easily tell. But yeah, having a lot of fun. I will keep in touch about how it works in the future. It'll be fun to see. So, as for other things, this plugin has, let's see. Oh well, one of the other things I did was I grabbed a bunch of soft side code. So some of you may have typed these in back in the day. And I took all the soft side code and I've added comments where the magazine articles had comments. And and this is all on my GitHub in the 6502 tools repository under the soft side folder. So if you're a soft side magazine fan from 1980-81, that time, and you were typing stuff in to learn BASIC, this is a lot of it. There's like this mini golf is pretty fun. I can show you what it looks like. I won't play it too much because it's noisy, but it's cute. Oops, it does that always. It's not a problem. Just the emulator does something weird with the memory. So there you go. Remember this? Do you remember this one at all? I believe it works with arrow keys and not a real joystick. Or I set it up to work with different keys. I've modified this. So yeah, it uses different keys. You can just aim your shot and then hit it as hard as you want. I believe the number is how hard you hit it or something. Yeah, 4. So I hit 4. Boom. Boom. Oh, I missed. And now I'll do like a 1. Woo, I got it. Okay, cool. So, right, it's just like golf, man. It's an actual game. All I had to do is type it in. And the cool thing is all the levels are just code. Each hole is like a little bit of code that does its own drawing. So if you want to make your own hole, it's pretty easy to do. You just have to like duplicate one of the other holes and then make your change all the drawing commands and screw around until you like it. Pretty neat, huh? And I just kind of like cleaned them up and organized them. And then there's saucer attack. You might have tried this one, or saucer formation it was called. And this one's kind of not so great, but we all typed it in, and then we were like, this isn't so great. Oop, I just lost. Hold on. So this is this game. You might remember this one. All you can do is move left and right, and when you shoot, your shots go really slow. And it starts out with 1 saucer, 2 saucer, 3 saucer. Boom. Now it's got 3 sets of 2. Oh no. And they just come straight at you. So it's not a sophisticated algorithm of attack here, but oh no. Oh, he hit me. So it does very accurate collision checks, and that's kind of what it demos, is how to do collision checking on sprites or player missiles, and it works. Of course, you may remember base attack from back in the day, outer space attack, which was also released as Pac Invaders with little Pac-Mans replacing these graphics. But this is another one by Sheldon Lehman, and it runs a little faster by not doing any bounds checking. So you can run way off the edge of the screen and it'll crash. I won't do that. But it's a cute one. I really like this one. Boom. That's a cute one. That was a great demo of player missile graphics, and also it does character graphics. It's changing the character graphic base to make the animation. There's other way. You can do that on a per line. If you have a clever display list and do some display list interrupt stuff, you can have that on like every line if you want. But that's the way it did it. He did it in that program, and everything scrolls. So he's got what's called course scrolling. So that's a course scrolling demo basically. There was also a game called Space Rescue, which we all typed in back in 1982, and that one looks like this. And this one is using basic character mode, as I recall. Ooh. So, what do you think? Remember this one? And this one goes like this. Oh no! You have to drop your ship and not crash. So you're guiding your ship from up on top down to the bottom. So you have to not crash. Ah, oops. Also, you're supposed to use your rockets, and I forgot. Because the same button that releases you also fires your rockets. So. Oh, I got so close. Right? But pretty good, right? That's a nice one. And then there's one called, there's actually a good one called Miner. Get that one. I kind of like this one a lot. I don't have all the comments in this one yet, but it's a pretty simple one. Oh, the other thing too is that programs will run faster if you call things near the top more often. That's another thing about Atari Basic, right? Dun, 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 dun. So the trick is I have to go over here to my little mining cart, go down to the mine, pick up some gold. Oops, but then it crashes. So obviously I have a typo. So got to work on it. That's part of the process. So if I took out these lines up here and replaced them with like comments or whatever, like that, or even just left them in as like, I don't know if you can do this. I think I've done this before, but basically you can also do this. Just say 0, and then there'll just be one line. And then you just at the end you just say 0, and all that line goes away. Or you can do it up here. Be like, oh yeah, here we go, 0, 0, 0, 0, 0. That's one way to do it. Before I had these comments, so, but it'll run faster if I do that. The whole program will run faster because every line is now at an earlier point, because it does a scan through the whole program when you ask it to jump to a line or go sub a line. So yeah, your go sub should all be at the top, and you should jump, just skip over that. And your lines should be as long as possible as well, like, because then it'll also run faster. Isn't that crazy? It's a strange feature of this language because of the way the interpreter works. Now, it's not the language itself, really. It's just the interpreter. You could, what I will do is when I make, what people have done to fix the interpreter was to make a line lookup, that made it much faster to get to a line. That's like one very obvious one. And there are other ways to do that, like But yeah, you make more tables basically. And then you would need, but the thing is, you would need 32K times like, 2 bytes. So you need 64K just for your line table if you did that um, in every situation. So obviously that's like not the best thing to do. Um, so yeah, it gets crazy. I did in my program. I remember I ran out of lines, like actual line numbers. I keep telling this anecdote that I wrote a program where I used up all the line numbers and I had to start consolidating into assembly code and user functions, USR function calls, which was cool. It forced me to learn a lot of stuff. There's also this microtext, and this is an actual text editor that was published. And it's a lot like, you can see it does work, wrapping and all that. Right? And you can go and you can move around with the cursor, which to turn off the controller here. Do that. But yeah, you can use the cursor keys to move around and stuff. I don't know if there's a plus key there, but return shows up as a little thingy. Let's see, what other keys do we have? Shift up arrow, that's strange. Shift down arrow does that. Shift right arrow does that. Okay. I believe this has to do with formatting, maybe. Like maybe that's, I don't know. I'm not sure what that will do, but as far as the cursor keys go, I thought I had them. Let's see. Shift, nope. Control, no. Hmm. There's got to be some way to do cursor keys in this thing. I'll have to read the documentation from the magazine, which is Soft Side, April 1982. So anyway, so if you want to get down and do like old school text editing, there you go. This is one I fixed up a little bit. This one didn't have a really good gameplay element, and it wasn't like laid out exactly like I liked, so I totally fixed it up. So check this one out. You'll like this one. This one was called Maze Search by David Bulkey from Softside, August 1980, way back in the day. So you have to go through the whole maze and get all the gold. And I did some tweaks to the colors and stuff and other things to make it more nifty. And I think it changes colors between levels as well. Ah, it's on a timer. And the other thing I did was I had it so it stops the timer when you pick up a chest, which gives you a little more time to actually finish the maze, because otherwise it just goes too fast for the number of. I think there's like you can set a number, but I think there's 23 of these things or 24. Now look, you have to go way back and look at all the time running out. Almost done. Right? It's not much, but it's still pretty fun. And this is all with the joystick. I'm using the keyboard and joystick, but I made that and I added the music. That wasn't in there before. Uh, and now when you press the button, it goes back, draws another maze. Um, and I like that it leaves it on the screen while it draws. You can make it draw faster by not showing it, but I like seeing it. Also, I fixed up the maze algorithm so it's much faster. That was another thing I did with this. So it actually generates the maze much more quickly and then confirms the maze is completed more quickly. Still takes a little while, but and then there you go. And then also I made the timer count down instead of counting up. So that's the whole trick I did. Um, only it already had the oh, and I think it also might have been tallying across the bottom. No, I don't think it tallied left and right. I'm pretty sure it was already set up to do the timer on the left or the timer and everything on the side. I like it's a cool way to do it. Use the it's a good use of the space. And I always like these very chunky like pixel modes for games. Like they give it some character, you know. But you can mix and match as well, which is cool. Like if you only need chunky graphics for one section of the screen, but you want finer graphics for another part, you can do that. Um, in text mode, there's a cool trick where you can use you know, the quarter size pixels inside the characters to make things. There you go. And you can do graphics that way, like bitmap graphics in text mode. And I believe someone, maybe me, at one point I did write a little routine to do like in character mode to have like if it was a 10 by 10 block of characters, it could do a 20 by 20 block of pixels, and it would just look like it was pixels. But it was still only one color because text mode. But that's fine, whatever. So that's pretty fun. So that just goes around and around. You just keep repeating it over and over. But better than nothing, you know. So that's Maze Source 2. And then, of course, Hopper. I don't know if I optimized this much yet. This one's pretty optimized already because it has some user like assembly code in it. And it was written by Rich Bouchard, who translated it from and Alan Zett. And it was originally written. Yeah, this was a project like kind of sponsored by SoftSide. They got all these authors together to each one do a different, platform version of a Frogger game. And this is the version that was done for the Atari, and we all typed it in in 1982. Uh, and I was glad I did. It was pretty good. I do believe it worked almost the first time. There you go. A game of skill. Press button to start. Oops. I might have to start again. There we go. I had it in turbo mode. As you can see, it's a pretty faithful little Frogger. Does a pretty good job of simulating the whole. Ah, oh, I didn't jump in time. See, it's a little bit sluggish because it's reading the stick like in between animation frames. You could imagine very readily turning this into like assembly or whatever, and making it a bit better. But frankly, there was a very good assembly language version of Frogger. The cool thing about the type-in magazines was, it came to your door in paper form, and from a piece of paper, suddenly you had a game. Just your eyeballs and your fingers. It's a really weird way to do it, but that's how we did it back in the day. Um, Programs like this were small enough to contain 4 versions in a single magazine. It was great. And then there were special editions of those magazines published with like, just the type-in programs like separate and then with a disc along with them, of course. Um, and those discs are, now available online. You can get them. I grabbed a bunch, and that's where I got a lot of this code that I'm cleaning up is from the discs themselves. I just, you know, run where I can, where there's actual basic code. I grab that, and then I just bring it in to my 6502 tools and clean it up as I'm doing with the source code for Atari Basic now. Part of the reason also I'm doing it is really because cool sound effect. The other reason I'm doing the cleaning up of the basic is really kind of for the benefit um, of the AI, because the PDFs are wrong. Like they're OCR'd and they have like, there'll be a 5 where there's supposed to be an S, or there'll be an 8 where there's supposed to be a B and all that. And they're just wrong. The embedded translation is wrong. The AIs do better when they read them, but they can still get that wrong too. Like 8s and Bs are very particularly hard to tell apart in a PDF form. without like zooming up a lot. So, and I don't expect to have AI ingest an entire like PDF worth of, every page of a long source code when most of it's already been typed in, and all I have to do is just, do my part to take this mess, which was the original one that was typed, that I downloaded from Atari ROM, I think is the name of the repository on GitHub, Atari ROM. And this is made for CA65. And although it's pretty good, there's a lot of places where there's like byte where it should be like a branch. And some of the branches are messed up and labels and stuff. So because it's containing 3 different versions, it has revision 1, 2, and 3 are all represented in this one source code. So I wanted to keep that, like all the representations, all the versions, but at the same time faithfully make it look, give all the comments that are in the original code. So I've been kind of going through and adding them here and there, but there's big areas that I haven't done. But it's just kind of like each area is I can focus on when I'm doing my tokenizer. I'll come back to the tokenizer area of the code, and I'll examine it and I'll look at the way it's doing in its loop and how it deals with certain questions, which is kind of like that's kind of the fun part about working through this is like you think about, okay, how would I do this? You know, um, how would I do this if I were, writing my new parser here in Python? And then you go and you look at how they did it, and you're like, oh, that's clever. Very often it's like beyond what you would think to do, or they're just doing something in a way that they're forced to do because of the limitations of the platform, and where you would just go, oh, I'll just throw another array at it or another more memory, um, more scripts, more functions. Um, but one of the cool things is I want to take the Python I have, and eventually I'll take parts of it and break it out into library form. So that's important. And then those will be available. Like you could, use like pip probably to get stuff like that. So that could be cool to have some of the pip elements to be able to get libraries um, that do this parsing of an Atari Basic file that can tokenize an Atari Basic source code file into an Atari Basic BAS file and all that, and just have it, I know I could just rip it all out of this code right here or out of the actual emulator itself. But again, the plan here is to get 6502 tools to work without an emulator. No emulator required to go from list to base or basic back to list and to run the code to some extent. I obviously can't do everything as far as running the code. Like there are going to be definite issues. Um, for example, like when you want to draw pixels, where do you draw them? So I'll have to like, when you want to do like player missile graphics or, kooky stuff like that, obviously it's not going to run. The point of having I want to at least do the tokenizer. Tokenizer is the most important part. The runner is less important. Like that's kind of what the interpreter, what the emulator is for. It has everything you can do to run. But the, to the extent that I can run parts of it and do things like even plotting colors inside of a Pygame window or whatever, like if we can do that kind of stuff, that would be nifty because then you'll be able to take stuff, prototype it without having to run an emulator, and then you put it in the emulator, and then you can start to mess with it. The other thing I want to hopefully be able to do is like make the Atari Basic syntax that you're typing in like you don't have to have line numbers, no line numbers, and it'll just do a translation layer where it'll translate from some messy, the version that has no line numbers to a version that creates line numbers and sticks them in. But if I also have a tokenizer, then I can skip that step and just artificially create the line numbers inside the tokenized final version of the program. Uh, and it'll just be like, yeah, it has line numbers, but they're, you never have to actually ever interact with them or see them. So that could be kind of cool. So that's what I'm looking at. So yeah, do keep checking this out while I'm working on it. If you're into the old soft side and compute magazines and you want to like kind of reminisce about that stuff. I think there were some stuff in even Byte magazine had some type in stuff back in the day. Oh, here's one. Defense. Boom. What could defense be? Oops. That's right. The game that looks a little bit like Defender. It's nothing like Defender, but well, it has the mechanic of, you're on a scrolling landscape and these little aliens are coming towards you, and when you shoot them, they they go down, and you can crash into the land, which you can't do in Defender. But oh no! And yeah, that's this game. Cute, huh? So we all typed this in back in the day. Um, you can imagine ways of seeing this, improved. Look out for that. Those things are crazy. Smiley faces are 100 points or something. 200 points. Ooh. And or maybe it's random. I don't know. Cool thing, I can go off the top without exploding all day long. So yeah, pretty neat little game. Very simple. You can't turn left and right. All you can do is go right. But that's fine. But it gave you the limited experience from a typing game of playing Defender in Basic. There was also one called Codfish. Oh, this one's kind of cool. This one is definitely optimized. This was from February 1984, so it's got a little more of that, you know, assembly code, which is why everything's moving so fast. I think that little guy is moving under the control of an of assembly routine, right? So yeah, you just shoot this endless shooting gallery. That's this game. It doesn't make any sound effects for shooting, which is sad. Anyway, that's a silly one. But and then there's a game called Changing Hearts, which was pretty neat. It was like a puzzle game, and I believe this one is just like instructions. Yes, so you can see if you want go from this pattern to this pattern by choosing light hearts only. These are the position numbers, and it'll swap the positions depending on your choice. So, for example, if I say center square, all the ones around it will be reversed. If you choose the middle square on an edge, the whole edge will be reversed. The ones above and below, or the ones to the left and right. If you choose a corner square, uh, a square including that corner will be reversed. So the square around it basically will be reversed. So that's the puzzle. And if you end up with all dark hearts, you lose. Um, and that's it. You can reset with I. That's it. There you go. Good luck. So here you have to choose 5. Um, and then you can go from there. Oops. Mm-hmm. So I don't know why it's going through the instructions again, but it does that. But it's a cool one. Try it out sometime. And then one last thing, Space Rescue. Is that the same one I showed you before? Yeah, I think it is. Yeah, it's the one where. Oh no, this is the one with. Yeah, it's the one with this. I like the Space Rescue. It's cool. Oh no! But I like that it's got the iconic, like, very basic. Yay! This little guy comes running over. See, I finally rescued someone. Inspired by Crush, Crumble, and Champa, obviously. And then I have to go back. And in this case, I can't. Oh no, my guy. Oh, he died. Sad. So that's that game. That's cute, huh? I love it. Very simple game. My aim is to make very simple stuff here, but inevitably my aim is to go beyond obviously Atari Basic and start doing more serious stuff in assembly language for both the Atari and the Commodore 64. Um, but I'm taking small steps with this little thing because I'm reacquainting myself with assembly language and what it's like to program assembly language, what it's like to clean up assembly language, what it's like to understand what's going on in a pile of assembly language, um, and sort of just getting used to the that just being in that mindset as I'm cleaning up this code, which is this is the next part. As I'm doing each little part, I'm capitalizing the bits that are from revision one, leaving the ones that are not in revision one lowercase, just to make it easier to see. And yeah, and this will be, once I finish this, I'll put it in my pile in the 6502 project. It'll be there. And its purpose will be essentially, once I get it to assemble, to have a running comparative version of Atari Basic, and I'll be able to maybe able to run this in a different environment where I can just have it run by itself in like you know in a command line setting and output its results in, or dump its memory or whatever at the end. I could do something along those lines using a little. I don't know. There's all kinds of options for running 6502 now inside of like pretend environments, and this is no exception. Like the one thing this has is like there is an OS behind it, so I can't like just use this by itself. It has to run in Atari land. So, but the cool thing is you can compile this separately as a cartridge and then load it into Atari land, and the OS is there and ready to go. There's no linking step involved. You're just calling things you know where they are. So that's pretty much where they are in the OS. And with the Atari, there's no particular like it's not a BIOS where you call a jump table and the jump table can change when you're calling. You have to know which OS you're calling, or if the OS is smart, it makes jump. It makes the old addresses jump to the new ones. So in general, like yeah, it's a fun project to see what's going to happen. The part I'm really looking forward to is definitely getting the tokenizer finished, because that's been working on that idea for so long and just wanting to have it work, and like it'll be so cool when I see my uh, LST program being tokenized into uh, faithfully tokenized into Atari Basic. Then when I list it, it comes out just right, and when I run it, it runs just right. Like it'll just be neat. Um, and having accomplished that, and then I'll be able to actually use that as a tool in my pile. But yeah, it's one of those things which I know like a lot of folks will approach like scientifically, and I don't know, it's almost a game for me. It's like uh, as all code is. It's like I like it when it can be fun, when it's at a fun level, when it's not serious. Like there's no one cares about this. I'm the only one who cares about making a basic tokenizer for Atari Basic at this point in history. But but having once it's there, it'll be out. The cool thing is it'll be there. It'll be written in a very simple language, Python, and everyone and their sister knows Python and can like totally decide whether they like what I did or not and fix it up and make it more like the kind of Python they'd like. Or use like you may end up using struct library and where I skipped it, or something, because the structures in here are so simple I don't need it. But you might decide, hey, maybe structures are good. Let's use that. The other thing I'll do when I clean this up is just kind of like I could also fix bugs, but I think revision two fixed and revision three fixed most of the bugs in Atari Basic. I think that I'm not going to find much, but there are a couple places I can see where I can optimize. Like there's at least one JSR RTS pair that could be a JMP here and there, and then if I could think of other ways to optimize it, I would. But in general, anyone who programs 6502 is already a pretty good optimizer. It's one of those things that you just have as a natural ability. If you're in 6502, you kind of have to. So let's see. Oop, getting everything formatted is very helpful. So I'll come back to this later. Uh, anyway, I'm going to go and get myself some beverages. Uh, got some OJ waiting for me. Go out for a run, and be back at it tomorrow working on the Marlin. And over the weekend, we'll get that release out. Work out those last bits of bugs. Meanwhile, think retro thoughts, because that's where the fun is right now. It's my escape from the horribleness of the world. And I hope you'll join me in my escapism. Don't forget to check all the links below. I could definitely much need your support to keep Marlin going, to keep my little side hobby viable, to make me not feel guilty when I do things that are fun. And I will talk to you all later. Cheers.